Hello my juniors, welcome to another renal physiology lecture series. It's your great science tutor Lorenzo, and today we'll be talking about the Juxtaglomerular Apparatus. The Juxtaglomerular Apparatus. In our previous video, we started the series with talking about the nephron, which is the functional anatomy of the kidney. Then now we are talking about the Juxtaglomerular Apparatus. So if you have not watched that one, go first watch that one before you come to this one. So if you are just new to my channel, make sure to subscribe and turn on your post notification button so that anytime I drop any video, you'll be sure to be notified. So if you want me to make any video for you, just put the request down in the comment section and I promise I'll make that video for you. So now let us jump right into the video. So starting with the Juxtaglomerular apparatus, what are they called? What is the meaning of Juxtaglomerular apparatus? From the name Juxtaglomerular, near the glomerulus. Juxtaglomerular, near the glomerulus. Now they are specialized organ. They are specialized organ near the glomerulus of each nephron. So they are specialized organs that are located around or close to the glomerulus of each nephron. So they are scattered around the glomerulus. So they are not close to the bone marrow capsule. They are not close to the renal tubule. They are just on the glomerulus, and the function is localized to the glomerulus of the nephron. So now they are divided into four. So you have the first one being the Macula Densa, which we talked about in the last video. The Macula Densa. The two, we have the Extraglomerular cells. The Extraglomerular cells. Now the next one is the Intraglomerular cells, or you call them the glomerular cells. So the last one is the Juxtaglomerular cells. Don't forget. So we have the Macula Densa, you have the Extraglomerular cells, you have the Intraglomerular cells, and you have the Juxtaglomerular cells on the own. So picking the first one, which is Macula Densa. So very easy. Like we said in the last video, the Macula Densa is present in the thick ascending limb of the loop of Henle. The thick ascending limb, or the thick ascending segment of the Henle's loop. And what is the function? Like I said, it is a sensor. It's a sensor of sodium chloride, of salt, or particularly sodium. So when it senses increase in sodium, what happens? It reabsorbs it into the vessel recta. So it reabsorbs it into the blood directly, into the vessel recta. So it's a sensor of salt. It's a sensor of salt, because I said that in the thick ascending limb, they reabsorb sodium chloride and potassium. So when it senses there's high level of this in the blood, what happens? It reabsorbs them into the blood vessel, to the vessel recta. Also, the Macula Densa also secrete thromboxane A2, which is a derivative of prostaglandin. So they secrete thromboxane A2, which helps in clot formation. Aside from being a sensor, so they secrete thromboxane A2. So the next one is the extraglomerular cell. The extraglomerular cells. Now the extraglomerular cells is very simple. They are cells that are scattered in the triangular area. There are cells that are scattered in the triangular area, like you are seeing your screen now. There are cells that are scattered in the triangular area in between the Macula Densa and the afferent and efferent arteries. They are specialized cells, or they are cells scattered around the triangular area between the Macula Densa and the afferent and efferent arteries. They do not have secretory granules, so they don't have any secretory granules. So the next one is the Intraglomerular cells, or called them the glomerular cells. They are intra because we have talked about the extra. Extra is in the triangular area between the Macula Densa and the afferent and efferent arteries. They don't have granules, so they are agranulocyte. But this one, they are granulocyte because they have granules. They are secretory granules because they are phagocytic in nature. They are phagocytic in nature. Now, since they are phagocytic in nature, they secrete what we call glomerular interstitial matrix. Glomerular interstitial matrix together with cytokines. Together with cytokines and prostaglandins. So this is what they secrete. Now, moving on here is that these cells, they are present in the capillary loop. So they are present in the glomerular capillary because they support the glomerular capillary. Why the extraglomerular cells are outside? They are not inside the capillary loop. So they support them and help in the contractile property. They help in the contractile property to resist or to inhibit larger molecules from entering into the kidney. So they help in regulating GFR, glomerular filtration rate, by contracting penetrating pores of the glomerular capillary to prevent larger molecules from passing to Don't forget. So we have talked about the macula densa, we've talked about the extraglomerular Mesangial cells, and we've talked about the intraglomerular Mesangial cells. So the next one is juxtaglomerular cells. Just like the intraglomerular Mesangial cells, the juxtaglomerular cells are granulocytes. They are granulocytes, which means they have secreting granules, just like the intraglomerular Mesangial cells. They both have secreting granules. Why? Because they secrete important what hormones or enzymes that helps in what regulating what your filtration, which is your glomerular filtration rate. Now, just like the interglomerular cells that have contractile properties, which helps to what inhibit larger molecules from passing in. Extraglomerular cells are present in the smooth muscle wall of the afferent renal arteries just before they enter into the wall, the bone marrow capsule. So they are present in the smooth muscle wall, usually the tunica media and the what, the adventitia. So they are wrapped around that place and hold it like a cuff. So they hold it like a cuff, forming what we call a polar cushion. A polar cushion or the Parkinson. The polar cushion of Parkinson is when the juxtaglomerular cell is holding the smooth muscle of the afferent artery like a what cuff, which helps to regulate the inflow of blood through the what afferent arteries. Don't forget. So we talk about the macula densa, which is a sensor, and it secretes what we call the thromboxane A2. Talk about the extraglomerular cell, which is present in the triangular area between the macula densa, afferent arteries, and the efferent arteries. We talk about the intraglomerular Mesangial cells, which is present in the capillary loop. And this last one is the juxtaglomerular cell, which is present in the what? In the smooth muscle wall of the afferent what? Arteries. The next is the function of the juxtaglomerular cell. I told you they are granulocytes, which means they produce secreting granules, and majorly they produce hormones. Their function is that they produce hormones, and the hormones are renin and prostaglandin. The renin and prostaglandin. So picking the first one, renin. Renin has about 340 amino acids linked by a peptide bond. So naturally, alongside angiotensin, they form what we call the renin-angiotensin system, which we call the RAAS system. Now, one thing you have to know, renin is secreted from the juxtaglomerular cell. So when it's secreted from the juxtaglomerular cell, it enters into the blood and they act on what angiotensinogen and convert it to what angiotensin 1, which is a what a decapeptide. Don't forget, angiotensin 1 flows into the lungs and is acted on by angiotensin converting enzyme. Angiotensin 1 flows into the lungs and is acted by a lungs enzyme. It's acted by a lungs enzyme called angiotensin converting enzyme, which is converting angiotensin 1 to angiotensin 2. Angiotensin 2 is the most active form of all the angiotensin, which we will be talking about later. But angiotensin 2 is converted to angiotensin 3 by angiotensinase, which is a what is a heptapeptide. Angiotensin 2 is an octapeptide. Angiotensin 3 is a what heptapeptide. Now angiotensin 3 is converted to angiotensin 4, which is a what hexapeptide. Don't forget. Now the angiotensin 2, which is an active form, what happens to it now? It binds to what we call the angiotensin 2 what receptor. It binds to the angiotensin 2 receptor. When it binds to the angiotensin 2 receptor on the blood vessel, what happens? On the blood vessel, it secretes what hypertension. On the blood vessel, when it binds to angiotensin 2 receptor, it secretes what hypertension. Hypertension does what? Causes vasoconstriction of the blood vessel, increasing the blood pressure. So 2, what happens now? It also indirectly secretes what? Epinephrine. It's indirectly secretes what? Epinephrine. So when it secretes epinephrine, epinephrine binds to the alpha receptor, also causing vasoconstriction. Next is angiotensin 2 binding to the angiotensin 2 receptor on the adrenal cortex. When it binds to the adrenal cortex, what happens? It stimulates the what zona glomerulosa to secrete what? Aldosterone. So when you secrete aldosterone, what happens? Aldosterone will increase sodium level. It increase sodium reabsorption and sodium chloride also reabsorption. So when sodium is going, water goes, and also chlorine also goes too. So the next one now, it also binds to the capillary system. So it binds to the capillary. What happens? When it binds to the capillary system, especially the efferent arteries, when it binds to the efferent artery, it constricts the efferent arteries. When it constricts the efferent arteries, what happens? It decreases what GFR. It decreases what GFR. Now also in the capillaries too, it also binds to the intraglomerular Mesangial cells. When it binds to the intraglomerular Mesangial cells, what happens? It decreases the surface area on which the solutes or the filtrate are being filtered into the wall, into the bone marrow capsule. So it binds to the efferent artery, constricting it to decrease GFR, and it binds to the intraglomerular Mesangial cell to decrease the filtration rate. The next part is in the brain. What happens? First of all, in the carotid sinus, it binds to the receptor in the carotid sinus, inhibiting bioreceptor reflex. Again, in the brain, especially in the carotid sinus, what does it do? It binds to the receptor in the carotid sinus, which is the bioreceptor reflex. So when it inhibits the bioreceptor reflex, decreasing it, causing what? An increase in blood pressure. Next is that it binds to the angiotensin II receptor on the posterior pituitary gland, increasing the secretion of ADH. So ADH travels to the distal convoluted tubules. When it travels there, it increases water reabsorption. So the next one, first of all, it binds to the receptor on the carotid sinus, inhibiting bioreceptor reflex, increasing the blood pressure. Next one now, what does it do? It binds to the receptor in the posterior pituitary gland, increasing ADH. When it increases ADH, what happens? ADH binds to the ADH receptor in the what? Distal convoluted tubule, increase water reabsorption. So increasing water reabsorption, increase blood volume. When it increase blood volume, what happens? It then what? Increase blood pressure. So at the same time, what happens? Sodium is also reabsorbed at the same time. And also the last one, there's also increase in water uptake. There's also increase in water uptake, because when there's increase in water reabsorption, test will set in, and when test is set in, there'll be increase in water uptake. Don't forget. So in the brain is the carotid sinus to the posterior pituitary gland, and when it binds to the posterior pituitary gland, increasing ADH. ADH binds to the ADH receptor in the distal convoluted tubule, increasing water reabsorption, which increase blood volume and what? Arterial blood pressure. This also help in what? Increasing taste, which increase what? Water reuptake. The next one is that ADH minorly also what? Increases what? Growth factor. It increases growth factor, especially in the heart, causing what? Cardiac hypertrophy. Causing what? Cardiac hypertrophy, which also causes cardiac what? Enlargement. So indirectly, excess amount of angiotensin II is also bad for the heart. Why? Because it causes what? Cardiac hypertrophy, which enlarges the heart, causing cardiomegaly. Now also, angiotensin II and angiotensin III are very important too. They have the same function of angiotensin II, but one thing you have to know, that angiotensin III and angiotensin IV have more what? Cortical stimulating activity than what? Vasopressin activity. The next one is prostaglandin. So prostaglandin is secreted by the intraglomerular Mesangial cells. Like I said earlier, the intraglomerular Mesangial cells are what? Phagocytic in nature. Since they are phagocytic in nature, they secrete what? Cytokines, prostaglandin, and what? Glomerular interstitial cell matrix. Two cells secrete prostaglandin, which is the what? Intraglomerular Mesangial cells, and what? The type 1 what? Medullary interstitial cells. So I hope it all made sense, and you have stayed with me up to this time where I talk about the glomerular apparatus, starting about the Macula Densa, the Extraglomerular cell, the Intraglomerular Mesangial cells, and the Juxtaglomerular cells. You have stayed with me, and now I talk about the RAAS mechanism, starting from the renin stimulating what? Angiotensinogen to angiotensin 1, from angiotensin 1 to angiotensin 2, from angiotensin 2 to angiotensin 3. I hope you understand it, and I hope it all makes sense. The video is too fast, just slow it down. I'm just trying to conserve the video so it will not be too long. So just slow it down, or use the YouTube word auto subtitle, and you understand it very well. You can also use your textbook. You can also use your textbook to understand it. Now, continue to like, subscribe, and share my videos, and also watch the nephron video before you come to the Juxtaglomerular apparatus, so that you understand how I started about the function of the nephron to this place. So now I'll be seeing you in the next video, which is the process of urine formation. Bye bye.